Hello, in this video we're going to use the inverse matrix method to solve a system of linear equations. So we have a demand and supply equation and we want to solve for the two unknowns, the variable q and the variable p. And like I said, we're going to use the inverse matrix method. So first thing we're going to do is we're going to get the constants to one side of the equation and the variables and coefficients on the other side. And then we can write this in matrix equation form. Matrix A will be the coefficients on the variables. So we have a 1 on the q and a 2 on the p term. And then in the bottom row we have another 1 on the q, but this time a minus 2 on the p term. And then our X matrix will just represent the unknown variables. And our B matrix will consist of a column vector of the constants. So the rule here to solve a system of linear equations using the inverse matrix method is if we do the following. We want to solve for the inverse matrix of A, this coefficient matrix, and then if we multiply it by matrix B, we'll be able to solve for the unknown variables. So if the inverse of matrix A exists, that is the determinant of A is not 0, we can solve for Q and P by multiplying the inverse matrix of A, that coefficient matrix, the inverse of it, by the constant matrix B. So let's get started. Here's our coefficient matrix. We're going to set up an augmented matrix with the identity matrix on the right. We'll use row operations to transform the left-hand side matrix into an identity matrix. So here we have the coefficient matrix on the left, and here we have the identity matrix on the right, just ones along the principal diagonal, zeros everywhere else for the identity matrix. And so, like I said, what we want to do is do a number of row operations to turn this left-hand side matrix into an identity matrix. So we want to turn this left-hand side matrix into an identity matrix. So we already got a good start here. We have a 1 here in row 1, column 1, but we need a 0 underneath it. And the way to do that is subtract row 1 from row 2 to get the following. So 1 minus 1 is 0. Minus 2 is minus 4. 0 minus 1 is minus 1. And 1 minus 0 is 1. Our next step is to get a 1 in row 2, column 2, right here. We want to turn this minus 4 into a 1. Again, trying to get this left-hand side matrix into an identity matrix. So just rewriting the last result. We're going to multiply row 2 by minus 1/4. So 0 times minus 1/4 is 0. Minus 4 multiplied by minus 1/4 is 1. Minus 1 multiplied by minus 1/4 is positive 1/4. And finally 1 multiplied by minus 1/4 is minus 1/4. Our next step is to get a 0 where this 2 is. So in row 1, column 2, we need to get a 0, and we will have converted our coefficient matrix into an identity matrix. So one way to do that is to multiply row 2 by 2 and subtract that result from row 1 to get the following. So 1 minus 0 times 2 is just 1. 2 minus 2 times 1 is 0. 1 minus 2 times 1/4 will just leave us with 1/2. 0 minus 2 times a negative 1/4 will leave us also with 1/2. And now we're basically done. The inverse of our coefficient matrix is what is left over here on the right-hand side. And just a reminder, our coefficient matrix and our variable matrix. So now we need to perform this calculation. I'm going to take this inverse matrix and multiply it by this column vector of constants. And so now the calculations, 1/2 times 70 plus 1/2 times negative 10. And then in the bottom row, we're going to have 1/4 times 70 plus minus 1/4 times negative 10. And then this top row will simplify to 30. This bottom row will simplify to 20. And we have our answers. Q will be 30, and the price would be 20. Okay, that's it. I hope you found this video helpful.